team. I'm going to start the recording here so that folks who come along later can check this out. Andrea is going to talk about a bunch of really cool new work from the Logic Liaison. So thank you very much, and take it away, Andrea.
Thanks, Sean. So yeah, I will go ahead and just share my screen real quick. All right, so like Sean said, I'm a member of the Logic Liaisons led by Johanna Lumba and Richard Moffitt. As a group, our goal is just to produce a cohesive set of templates and tools that will help you make data frames of variables using concept sets that you want for your project, as well as templates to assess the density of those variables across patients or visits, as well as across sites. So earlier this year, Johanna presented on the first of these fact templates, which was called the PCR EUG confirmed COVID-19 patient fact template at the time. That template has actually evolved to include more variables and features for not only the PCR EUG confirmed, but also the UO7.1 diagnosis confirmed COVID-19 patients. And so if we look at this slide, that's actually this group on the left-hand side here. And they have this special index date, which we are using the earliest of either. So either their test result or their COVID-19 diagnosis as their index date, and deriving a bunch of variables based on that. We've also recently published a new fact template for all patients in the enclave, so covering everyone on this slide. And so this all patients template includes just that, all 15 million of the patient records we currently have, but primarily differs from this confirmed COVID-19 patient template in that the facts are not associated with a COVID index date. So some facts are not there or a little bit different just because we don't have a good index date or any index date for some of these for the group as a whole, essentially. So as of right now, users of these templates can identify the confirmed COVID-19 positive patients within the all patient template by joining in the patient IDs from this confirmed template. In the near future, we're hoping to add to that all patient template indicators that will allow you to separate not only the confirmed patients from the rest, but also further delineate which of the remaining patients are either possible COVID positive or the matched controls that are brought in from each site. And so these controls are defined by each site using their control maps, and we're waiting on just a list of exactly who those are. Once we have that, we can then determine who this middle group of possible COVID is, because some of these are pretty hard to find in general, and also just difficult to find in level 2 where there's date shifting and this, that, and the other. And so it's really not too clear, but this group would include the early 2020 suspect cases, someone who only has a positive antibody test, which may or may not be from an infection. It could be from getting the vaccine. It also includes folks who only have a long COVID diagnosis code, the UO9.9, or a long COVID clinic visit recorded, but no record of an acute infection. And so for both of these groups on the right-hand side, there is either no index date that's applicable, or it just varies so much because we have no way of knowing when their acute infection was, that the all patients template just finds and calculates facts for everyone on the same playing field, essentially. And then our confirmed COVID positive template gives you a deeper dive into COVID related information. Do we have any questions on the division of these subcohorts? Great. Okay, so since we have that, I will go ahead and just show you the templates themselves in the knowledge store. So starting from the N3C homepage, we'll follow this tile into the knowledge store. And then once you're in here, you can just search Logic Liaison. And all 5 of our current templates will have that tag, the Logic Liaison template tag. And so right now, like I said, we have 5, 2 of which are the cohort related templates that provide the derived variables. And then the remaining 3 are actually data quality templates, thanks to contributions from another Logic Liaison, Evan French. And so those data density, or sorry, the data quality templates, there are 2 kinds really. So there's this first one, the data density by site and domain, which you can use to get sort of a general lay of the land as far as data richness in each domain from all the sites. And then the fact density by site and the systematic missingness by site and study variable. Those are more useful once you've produced an initial data set that you want to use for your studies analysis. And so you might want to apply either of these to kind of get a little look into the data quality of specifically what you're looking at. So first, I'm just going to show you the cohort related ones, and then we'll talk about the data quality ones. So starting just with this all patients knowledge object. Just want to point out that there are a lot of pieces to this. So we have a very dense README that has lots of useful information, but I'll point out some highlights for you guys in just a second. So I'll go ahead and open that up. We also provide those output data sets from the template itself. So you can decide to just use the visit level or the patient level final data set if you find that the facts described in the README are exactly what you're looking for or what you need, and you don't want to mess with coding or anything like that. You can pull those directly. If you do decide that you want to take a deeper dive into the code or maybe even modify the template a little bit, like with some parameter changes, then you can take a look at the example workbooks here. So we have each of these features has an LDS and a de-identified version. So you can go into either one, whichever your data access level is. And then if after looking in these and you decide, oh, I really like some of the stuff, but maybe not some others, or I want to add some variables or some flags or something, you can always import the entire template into a workbook of your own and modify it from there. And so in this README, we have several sections, lots of useful information here, but primarily I want to show you the data dictionary. So this gives you all the variables that are described in that final patient level table. The visit level table has many of the same ones, maybe a couple other special things that are specific to a visit level, so it has to be associated with the visit day, but then it collapses into this. And so you'll notice for this all patients template, nothing here is split by index date, or there's so it's just total visits per person, their total observation period, some demographics, and their data model information. There is SEOH information, social determinants of health variables for those with level 3 data access. And then some general facts, so BMI, long COVID flags, any concept set really. And then we have roughly 33 comorbidities that aren't listed one by one here, but it's just a record if the patients ever had that marked in their N3C record. And so if we take a look at the confirmed COVID positive template, we'll see that this knowledge object has all the same elements, so the README, datasets, example workbooks, and shared logic. But in this README, you'll notice that we do start to provide those special COVID index related facts. So if we go down to the data dictionary here, We have the date of their positive lab test, the date of their first diagnosis, and then we actually just find the earlier of the two, and we use this particular variable, this particular date, as the index date for many of the rest of these facts, really. So you'll notice from the all patients readme where I mentioned total visits, it's now split into number of visits before COVID and number of visits post-COVID. Same with really the rest of the facts in this template that aren't just patient related. So demographics stay the same, obviously, and then same with the SDOH variables, but anything where it's their condition or their events that have happened to them, just any encounter record, they are now split before COVID and post-COVID. Then and then, as I mentioned, we find several special COVID related facts and events. One of those is a COVID related or associated hospitalization that's just temporally associated with their index date. And so we find some things like if they've ever had IMV during hospitalization or ECMO, that type of thing. There's also reinfection, since that can only occur if they had COVID the first time. And then something like severity type that is detailed a little bit more in this community note that we find in this confirmed template, but it's based on those flags for IMV, ECMO, death, hospitalization that are temporally associated rather than causal. So we're not saying that this is why they were in the hospital or like that's because of their COVID, but just all related to the time around their index event. And then, like I mentioned before, we do have those same 30-ish comorbidities, but now they are split for if the patient has had that recorded before their COVID index or after their COVID index, or both. And so say you've looked through that README and you want to do a deeper dive and maybe do some modifications to the template. I'm just going to show how to import the template, but I won't show any real data, and I'll switch to a notional workbook in just a moment. But if you decide that you do want to import the template, you can just click on this shared logic. It'll bring you to this page for the template manager, and it'll have selected the one that you just clicked on. You click on add to workbook, and it'll just prompt you to name it something meaningful and save it in whatever project space you're working in. So if I was to do it in the Logic Liaison team, I find my folder, and then I would just click save. And so I actually have the notional data version here. So using synthetic data, we can take a look at the template itself. So here is just the basic template that I've just imported and I've run already so that we don't have to wait on that. It might seem like a lot, but just know that this first column is where we have all of the OMOP tables and other input data sets that are being brought in. This middle column, we have this specific cohort node where we are narrowing our patient population to those folks who had the positive test and or the US 7.1 diagnosis code. There's this intermediate node, which I'll explain in just a moment, but it's purely for making your life easier. And then this third column is just where we go through each of the domains and we look for the of interest rows of facts from those domains. The second to last node is that visit level table that I was telling you about. So if I were to open this, we would see that there is a row per patient per visit date on which there's at least some fact in the many columns here where there's a 1, which means that fact is present. And if I go back to the workbook, this final node is just a collapse of that table so that we have 1 row per patient. And so you'll notice there are unique patient rows, and then it brings in like the patient-related demographics and their COVID index date and stuff like that. So say you have looked through this and you want to make some small modifications. We do have a couple places where there are parameters that you can change, such as the lowest and highest acceptable BMIs, the height, weight for calculating that. We have parameters around the time frame in which we're looking for COVID-associated hospitalizations. So we're right now using the CDC definition of 1 day prior to 16 days after, but we've customized this for the past or the long COVID project to be 14 days in either direction, stuff like that. You can just change in this template view and then run directly without having to modify the code. There's also one here in the all facts table that is the reinfection wait time. We're looking 60 days after their index event right now, but you could bump it to 90 if that's what your domain team or your study determines is the more reasonable time frame. But let's say that's not like you're fine with those, or maybe you've modified those to be what you want, but really it's the facts, the comorbidities that we're looking for, or the concept sets that we're using that you want to change. So really that would bring this table into play. So this is just one that I've generated from a Fusion sheet, and then connected to this node where all it does is just connect it to the other one so that you don't have to manually change the connection to all 6 of the nodes that this gets put into. And so if you wanted to modify this, you could do so just by creating a manual entry table and then copy and pasting this structure so that you want the exact column names. And then let's say you want to keep most of this, but you want to modify some of it. You can just copy, you can select this corner and Control C for all of it. And you would paste into here that table. It just takes a second. Once you've done so, you can actually just switch the input from this table right here to the one that you just created. Just move that so it's more obvious. And once you switch that input to be your modified version, you could just run the template and it would use those. And so to show you an example of that, I've got one set up in this other branch. So here I made that manual entry table and just renamed it LL concept sets modified rather than our original Fusion one. And so I'll go ahead and come here to this intermediate node and switch the input to be the modified one. And then once that is run, we'll see the difference in this final data set. But before I go there, I just want to show you this table itself and compare these two. So you'll notice for something like cardiomyopathies, that particular indicator flag, we're currently using one created by Johanna that is just all caps cardiomyopathies. But if we look in this modified one, I've changed it to the VSAC cardiomyopathy concept set. And I've updated the domain to be whatever domains that concept exists in based on the concept set browser. And then You also want to specify whether you want to flag that in the pre or post, so whatever period you're looking in. Some of these facts, like the COVID regimen code for steroids, we're only looking during hospitalization, since that would be the only relevant time that we would find that. And some of these, like long COVID, would probably only ever occur post, so that's when we only want to know. And so I've specified just post here. So this first column, concept set name, is exactly what you find in the concept set browser. You just copy and paste the name in here. The indicator prefix is what you decide you want your variable to be called. The part where it's labeled before COVID indicator or post COVID indicator gets added later, so you don't have to worry about that. This is just the base of what you want. And then you'll want to specify domain or domains in which you see this variable. So you can see some of these are in multiple domains. And then the pre, during, post is where you just specify the time frame that you want to look for those. You'll also notice that another big thing that's different from this one that I've modified compared to the default one is that this is a one-to-one. So there's one concept set for this one variable that I want to create. But the way that the workbook is set up, you can actually map many to one. And so for something like chronic lung disease, for this indicator, I'm actually looking at all of these concept sets. And so anytime it finds any of these concept sets, it'll create a flag under the column chronic lung disease. Okay, so once you've made that modification, I've run that table. I'll just point out that something like, where is it? I've got pregnancy in this fusion sheet. So I've created one here that doesn't exist in the default. And so this table that is produced, if I were to look, we can see that it's created pregnancy before and post COVID. Whereas the default table that I opened a little bit ago, if I were to search for pregnancy as a column, it doesn't come up because that fusion sheet never specified that variable or the concept set that it wanted to use. So one important thing to add to that is that for any concept set that you're specifying, the code currently is looking just for the most recent version. And so if you would rather go by code set ID, you could actually just tweak this input data set to have a code set ID column and just switch this most recent version to look for that code set instead of the most recent version true. That's a planned future enhancement that we're considering. So it may be that you won't have to do that on your own. But any questions about modifying the concept sets or inputs or anything like that?
I had a quick question about the the node before the last one, the one where it lists per day. You said that it lists for every patient for every day during which they have a fact, which facts that they had on that day. If someone had a condition that started like on January 1st and ended on January 12th, but had nothing going on in between there, would there be a January 6th entry for that condition for that patient?
So it is flagging any instance in which that diagnosis or event is recorded in their record. So if they have, so like if they were to visit the doctor on whatever date this is, and obesity was recorded, it would flag that. But if they didn't have a visit in between that, or maybe it was for something else and obesity wasn't recorded, then it would not flag those. So it doesn't really consider the era in which the start and end date covers.
Got it. Thank you. That answers it.
And I'll just say, Sean, like that's important for us to not make assumptions around that, because something like the expanded version of, or the enhanced version of reinfection that the PASC team is looking at, they want to see when does a COVID diagnosis disappear. You know, if it's in the record in multiple visits and it goes away for a while and it comes back, when does it come back? And does that kind of coincide with the reinfection period? That kind of thing. And so we want to be able to detect it going away as well as coming back, and time relationships between that. And so we don't want to assume that something's carrying on even if it appeared at 2 bookend visits.
Got it.
And just a question, I think just my knowledge of the concept set number table is not that great. The code set ID, what's the advantage of perhaps using that?
Right, so here, let me go ahead and just find that table. So the code set ID is specific to a version of the concept set. So if someone were to update the concept set and add new concept IDs, it would generate a new code set ID. So if you wanted to pin to a specific one, you would want to specify by code set ID.
Okay, but you could always just say, if you just want the most recent version, you wouldn't need the code set ID.
Yeah,
Right.
exactly. You could just
Okay.
use the template as is.
Okay, great.
Yeah. Any other questions? Okay, great. So now I'll actually go ahead and just talk about some of the quality templates that go along with, or rather they currently just use our final data set as input. But really the quality templates could be applied to any study variable or study data set. And so for this example, I'll just talk about the fact density by site, and the systematic missingness ones that I mentioned are more so for once you have a data set that you want to use for your project analysis. So starting with the systematic missingness one, remember that this one is an all or nothing. Does this fact appear ever for any patient at this particular site that I'm interested in? And so you'll notice that this is just the COVID confirmed positive template. And then this is our final patient level table that is then fed into the systematic missingness template, which is only these 3 nodes. And so when I run this, it'll generate something that looks kind of like this, although this is a little different because it's the synthetic data. We can see that they're just all or nothing. So the 2 different colors, the light blue means there's at least 1 patient at that site that has that fact at some point. Whereas the black or the darker blue just indicates that no one at that site has this particular fact that we found, or it's just all zeros essentially. And so if we take a closer look here, we can look at diabetes uncomplicated post-COVID indicator. So for this particular variable, we see that most of the sites that are in the synthetic data have someone who has this fact found at least once. But from site 2019, there's absolutely no one who has uncomplicated diabetes post-COVID that has been found in their N3C record. So using this, you could see if there's a particular data partner that you may want to exclude if that variable is super important for your analysis. Or maybe there's a concept that isn't being found at all. So like COVID regimen corticosteroids, you may want to look at refining concept sets or considering different concept sets, stuff like that, that this table could just kind of lead you to, and then you can make decisions with your study team starting from there. So that's this one. And then if we take a look at the other data quality one, the fact density by site, it just gives us more details as far as like how badly it's missing, or maybe some sites have it, but not very often. And so in this branch, I've actually just imported a single, like the single output data set. So this is that final table that I've imported rather than having the whole template. So this is another way you could use this. And so, yeah, there's just the final table. So it could be your study generated table. It could just be the data set directly from the knowledge store object here. Or you could have the entire template imported here as well, but I just wanted to show a different use case. And so this template only requires that final data set and the manifest table. And then it processes that and it creates these 3 visualizations. So we've got standardized density. So it's just standardized by the number of records. A darker blue tells us that the site has more instances of that fact found than where there's a lighter blue color. We've then got this median absolute deviation. So let's zoom in, your 0 is the median, and then the darker the red means the more it's deviated from the median, but it doesn't really tell you, is it more records or less records, or like more instances of that fact being found or less. So there's also this view where it's directional, and the blue would indicate a negative deviation from the median, and the red is where it's a positive deviation. So there's more data density for that fact at a particular site. Any questions with the quality templates?
I'll just add that the data sets that underlie this are also available in the template. So if you wanted to look at those values, in your code and set some thresholds to say, if say the relative density of death at a site, if you go back a couple views there, if you want to set a threshold and say, if this is really deviating from the density of death, by a certain amount, then we would filter those sites out. So you can set thresholds instead of hard coding out the exclusion of a site. That way, if sites that have poor quality today enhance their data quality and then meet your quality standard, they would automatically be included when you reran your code. And also as new sites are added to the enclave, you might want to be refreshing your pipelines if you haven't yet frozen your data sets. And again, you might not want to be doing a kind of a visual analysis each and every time. So you can utilize the underlying data sets. And that colored bar to the left of each of those charts is you might have said this, Andrea, but that's the clinical data model. We don't see a ton of patterns on this, but depending on your particular variables for your project, you may see some distinct patterns by data model, and our fact tables also associate each patient with the data model that they're coming in under, that their data is associated with. And so you might also put in your code, like, we only want to include sites from 3 of the data models, 3 of the 4 data models, because we're noticing that the ACT data model does not include the kind of data that we're interested in. And then you would, again, dynamically be filtering out any patients that were associated with that data model as they come in. So just a reminder that you can start visually in understanding your project-specific data, and then you can kind of work backwards into a more automated process that you can write into your templates and also write up in your methods section of a publication. The most important variables here are your outcome variables, but you should look at all your variables, but especially your outcomes.
Great, thanks, Johanna. I did also want to mention, so Evan has very well set up this this template to work on pretty much any input data set, and that's why he's bringing in the manifest table, so that's generalized enough. This systematic missingness one, if you're finding that it's not working, it does rely on data partner ID, so your final data set does have to have that column. It does also drop a couple specific things that aren't really necessary to be evaluated in the visualization, just to keep the visualization a little bit more clean. So you may find that you have to just change this code to, like, if your data set never had city, county, state, it might throw an error there. So you might want to just modify that to get rid of the reference for a column that doesn't exist in your table. But otherwise, it can be used for any input data set that where you've got your study variables, and you just maybe you want to drop some other ones or something that aren't relevant to look at the density, but you do want to have as your final output.
And Andrea and several other members of our Logic Liaison team attend office hours on Tuesdays and Thursdays. And so anyone who needs help just following the workflow she just presented or troubleshooting any errors that might be introduced based on their own custom variables that they're using, please feel free to attend office hours and we can help you with that, or just interpret the visualizations and anything like that. That'd be helpful.
Yes, Sean?
I feel like you probably said this and I just happen to be spacing at the moment. How do you measure data density?
So it's looking at, for these two in particular, it's looking for the number of records with that fact.
Like normalized by the number of records in total, or just a
We do
Yeah, this one's
collapse on the
normalized.
day. We do collapse by day so that when repeat records are introduced just by the coding systems, like you might have, a drug represented 6 times in a day just because it was ordered 2 different ways, administered once, whatever, we collapse by day to reduce some of that noise. We do see different systems really varying in that way on a daily level, so we don't want that to bias the representation here. And then normalizing in the blue chart there, we normalize by the max representation by site. So let's say the highest representation for death was 5% of people at that site, then the 1 would be that site's patients, right? And then everyone is relative to that maximum density. Otherwise, death would be, as a very faint value on this chart if we don't normalize to the most dense site. Yeah, and of course, most dense is not always better, right? You might sometimes question things that are just way off of the norm, which is why that mean absolute density might be more relevant to your particular variable, right? When you're really expecting like kind of normal distribution of things or something, you might be interested in that one instead. So you can pick the best visualization or just look at the underlying data sets that support this.
Great. So that is really all I have in detail. So if anyone has any questions, please feel free. Or if you want to see something again or anything like that.
So I think the key takeaway here is that you can rapidly make data frames that are on a person level and also a person day level. So if you need to look at time relationships between your various concept sets, you can look at the penultimate table. The second to the last one has the visit day level facts, and there are columns in that that also flag those events. So you get, you know, for every row of data, was it part of say a COVID associated hospitalization? Was it part of any hospitalization at all? Right, that kind of thing. And so depending on your needs, you might want to do kind of a derivation of that second to last node where you make your own index event. Sorry if you've already said this, Andrea, before, but we're also working on a template to support that, make that even easier for you. But just familiarizing yourself with that table and looking at all of the columns in there is probably a good thing to do if you need to do anything with time relationships and generating your own. If all you need are the relationships around that COVID indexed event, then you probably have what you need with our tables, and you just have to input your custom concept sets. If you do want to make some custom changes like that, we recommend adding sister nodes to this template. So, you just add like a node alongside that might enhance or manipulate the node that we have, or maybe you want to copy it and do something very similar and use the same inputs that are here on the screen. If you do that, then without changing to the code view and changing to your own transform, if you keep it in the template kind of a format, then you can easily update to new versions of the template as they come out. So as we continue to enhance this with community variables, like the vaccine variables are coming in next week, right, Andrea?
Yes, that is planned for the very near future.
Yeah, so we're just waiting on a knowledge object to appear in the knowledge store, but once we get that little technical step checked off, then those will appear, and you can just, if you imported this template today, then you would come in, say sometime next week, and you would notice that your template's out of date. You'll have a little alert in here, and then you would follow the steps. I think we have those documented as well, the steps for updating your template. So whenever possible, leave the template as is and just use kind of sister nodes along the way to enhance it for your own project. The most basic enhancement is putting in your project specific concept sets. You don't have to modify anything, you just use the template as is. And there are some other variables that are templatized, like BMI thresholds and things like that. You can click through the nodes. But if you need to do, again, something really custom around, like, you want to look at time frames around long COVID, and you have some very specific time frames in mind, you can do that using the second to last node as your input, and just do a transformation off that. Sean, is there anything else you can think of that might be helpful for us to share?
I love that they're sort of very configurable and composable, like the idea that you guys have this sort of like patient facts table, whether it be the all patient facts or the COVID positive patient facts. And then you can do a lot of configurations there. And then on that, you add on the data density and the things like that. So people can really easily sort of do data density according to whatever variables they're interested in. That does lead me to wonder, does that mean that for those downstream ones, like the data density, is the workflow to start with, getting yourself the patient facts table and then adding the template onto that? Or is there a way that you can just jump directly to like the data density one with the default variables?
You can look at the defaults. We have a second set of those density visualizations available for the OMOP data at large. So you might want to look there just to see, like, for each domain, what's the density of all the domains. But then, yeah, I think that for your project, the workflow is exactly what you said. Use this first template to make your project specific fact tables. Once you have those fact tables, then you import the visualization templates, and you swap out the default input with your own study specific table. And I guess it's also good just to know, a lot of people get asked by their PIs, or they've got a PI on their DUR, so they're allowed to get patient counts, verbally without any data export, or you're allowed to share screen with them. They want patient counts. Just to highlight the very obvious here, those last two tables are very good for patient counts. So the second to last one, you would want to filter on whatever columns you're interested in, and then look at the person ID unique, because there are multiple rows per patient in there. So you view stats. So Andrea can show you this. She could do that, and maybe say it like happens during a hospitalization. So she could look at the hospitalization column and flag that column. And so, because the screen is small for me, I don't know what variable she first picked. Sorry.
So I picked heart failure.
Heart failure.
Um,
Okay, so during a hospitalization, she could then filter for values of 1 in both those columns here. And then go to that person ID column and view stats. And then this gives you a very fast count of the number of times that heart failure has ever occurred. So we have 1,299 rows in the notional data. This is fake data again. That many times that has appeared during a hospitalization. And we also have the unique number of patients. So actually in this particular data set, it's just once per patient, I guess, that this occurred. But in the real data, you're going to have fewer unique patients because it will have been coded multiple times during a hospitalization. And then you can also do other neat things here to filter your data, like if you had age or something and you wanted to look just at pediatric patients, she could go to the age column in here.
So this table doesn't have age, but the summary table
Oh,
does.
sorry about that.
So you could join that in.
Yeah, or you
from
just
there.
go to the summary table and you could look at age there, and then you could filter to certain age ranges very quickly too. So these are really fast ways to get counts if you're doing feasibility. If you're doing some more complex Boolean logic and it's not just kind of a this and this and that, then you might need to do it, in your code workbook, but you can again use these flags to do that, where this is a 1 and that is a 0 and this is a whatever. So this is a really, good way to also explore. If you notice based on your data quality, again, that certain clinical data models need to be excluded, you can do that quickly in here before ever doing it in your code workbook. You can look at distributions of things like BMI, and you could see how it changes if you remove the sites that you don't like. So there's a lot of exploration you can do just by opening a data set here. And before even going into Contour or into your code workbook to work with the data. Yeah, so this table is a unique row per patient. Sorry, Andrea. So the unique number should always match the total positive in this final one, but it's still always good to look for distinct, just in case you forget which of your tables you're in when you're looking at stats on these things. Yeah, go ahead, Andrea.
Oh, I was just gonna say, I forgot to mention, like in this column view, you can actually see all of the 30 some conditions that we're looking for from the start. So these default ones that we've brought in, this first set is before COVID, and then we've got those during hospitalization associated ones, and then your post-COVID.
And you can search for a column up there at the top. And do you want to maybe use that first or look for hospitalization, Andrea, and then show them the definition of the COVID hospitalization? COVID associated hospitalization. I think it's the last at the bottom there. You expand that.
Yeah, so because this is notional, I didn't put the definition, but I'll just go to the README.
Yeah, but in the real data, right there, when you expand the column, you'll have the definition of that variable, and also the concept sets used to define that. And so if you're wondering COVID associated hospitalization, what's the time frame and stuff, you can go to this fabulous README here. Or you can just expand that column description and you'll have the associated logic and concept set names right there. So you can go and, make sure you agree with those and see if you want to do any customization from there.
It's super excellent.
Yeah, Scott, do you have any questions?
Yeah, thanks, Johanna. This is really interesting and it's helpful for me. I haven't sort of looked this deep into it. So I appreciate, Andrea, the information. The question that I'm thinking about, and it goes back to our discussion a little bit yesterday, Johanna, and it's maybe more specific to after a concept set's created, looking at that concept set and the information that's provided on it to get a sense on how often that variable was reported or collected in the data itself. And I have an example that I'm thinking of, and it's angiotensin converting enzyme, which is a concept that I created last week, and it's related to a research idea we have related to myocarditis associated with COVID and vaccines. And I built that concept set, and then I was sort of looking at some of the reporting on it, and I was trying to interpret just how potentially valuable that might be, because that lab measurement's not a real routine piece compared to a serum creatinine, for example.
Yeah.
So I'm trying to figure out, how I can sort of learn how meaningful that lab value concept set might actually be in terms of a research project.
Yeah, thanks for that great example. So it hits on, useful ways that you could rapidly, implement this pipeline. So what's a common diagnosis associated with that measurement?
Well, it could be any possible collection on a patient with COVID.
Yeah. So let's say there was something like hypertension or something. I'm just making it up. Okay, that's a diagnosis associated with it.
Sorry, if you wanted to match it to something that I'm really curious about, it would be myocarditis.
Okay, so let's say you have myocarditis. So our template does support that rapid, customization. You would go to that concept set data frame where you customize it, and you would just put in the name of your concept set in the first column at the bottom down here. Name verbatim exactly as it appears in the knowledge store in the concept set browser. You type that in. The second column you put in without spaces or special characters the variable name that you want to use for it, and then the domains it appears in, and whether you're interested in pre, post COVID, during hospitalization, all three. You can put all three there, and then you would hit run, and the template will find that, and then you could use those things we just talked about. You could open up those final tables and do counts, or you could use the data quality templates strung on top of this. So you take the final tables, input into our data quality, and see all the kind of absolute density across domains and things like that. One limitation that your question highlights is that we do not cover measurements with this simple input table here. The reason for that being that we're afraid of introducing more accidental error from users if we support that. Is it definitely possible to do that? And to do that yourself, Scott, you would copy one of these nodes, like the conditions of interest node, make a measurements of interest that's a custom node yourself, and just change the input tables to it. It's very simple to kind of reuse our code here. But the reason why we don't do that for measurements is because the vast majority of the measurements data is not harmonized. And many people are looking at the values and then not realizing it's not harmonized data and coming up with some strange results. So we don't want to support that kind of misuse. But if what you're looking for is just the presence or absence of that code, and you're not really yet looking at the actual value of the measurement, you want to just know, like, was that ordered, right? Was that test ordered? And that itself is a signal. Then I would just take one of these nodes, make a sister node like this, change it so it takes in the measurements table instead of conditions, and we would again just run the pipeline, and you could do that with 4 similar but different concept sets, so that you could then get counts, look at density across domains, all those things, density across data partners, sorry. And we can absolutely help you with that in office hours so that you can do that. But it's a good way to compare.
I think what I would need is like a hands-on tutorial, because this is very new to me. And we've got, along with the office hours help, folks in our domain team that could help with it too. But, really it gets down to, matching that lab value to patients that have myocarditis listed, and it might be during a hospitalization or at the time of COVID diagnosis or within a window of time, just to get
Exactly.
a sense on, numbers of patients. And it reminds me of something I've used in the past called I2B2.
Yeah.
Others, yeah, others I'm sure may be familiar with it too, and I haven't used it a lot. But, it's the same idea to find out what
Yeah.
numbers,
Yeah. So we
and
would
the
take
power of an analysis.
exactly. So we would take that customization of yours, and maybe we have 4 different versions of a concept set you're interested in that are still up in the air. And then you've got some well-defined ones like myocarditis and obviously COVID and things like that. You get that second to last table or the last table, and you'd have all those things flagged. If you were just interested in the ones that happened during a COVID hospitalization, that last table provides those rows for you. So basically you'd add one more node where you filtered to those things. She showed you in an exploration, but in the code you'd say where it happened during COVID hospitalization, where there's a flag of 1 there, where myocarditis is 1, and where, and I'm only interested in these certain measurements for now. I don't care about all the other 100 variables. Okay, so you select those things, then you use our quality templates. And then you can look at just those. You can say within these myocarditis hospitalized patients, I'm now just looking at these 4 versions of this measurement, and I'm looking at how it varies, over time. And these are only the measurements that were captured, during the hospitalization, that kind of thing. You could use the second to last table as well for that. I have to think about which one's best depending on your detailed use case, but yeah.
Yeah, no, that's helpful. I appreciate it. I think, at some point, again, to try to help kick the training wheels off for me a little bit, I probably want to learn some more as we go along, but it's good information on the start end, so appreciate it.
Yeah, thanks for
Thanks so
contributing.
much. Yeah.
Yeah, great job, Andrea. Thank you for presenting all that. It's a lot to cover.
Of course. Thank you guys.
All right, well, I think that should wrap us up. We are at the top of the hour. Thank you so much, Johanna and Andrea and everyone else for stopping by.
Thanks a lot, everybody. Have a good weekend.
Have a good one.
Yes, thanks. Bye.
Bye.